This is the fourth lesson in our topic of elements, atoms and compounds. On this splash screen you can see some molecules. They're molecules of sodium hydroxide. Let's do the starter as we normally do. Quickly write 1 to 10 and write down all the answers you know, just one word, and anyone you don't know just leave out and skip on to the next one. So pause the video and do that now. Here are the answers. So I suggest you pause the video again and you can mark your answers off or make any corrections. Okay, today's topic is formulae, and we need to know how to name and write symbols for common compounds. We need to know the rules for writing formulae, and during the course of the video there's an angry policeman who will give us all the rules, and we need to know how to interpret chemical formulae. Just for the sake of good English, at the bottom right hand corner you can see it says if you're talking about one, it's a formula. If you're talking about more than one, it's formulae. I've made a little video on building molecules. Today I'm going to be building some molecules. I've got different colored balls to represent atoms, and I've got these plastic connectors to represent the bonds that hold the atoms together. So first of all, I'd like to do helium, and helium likes to be all on its own because it's a noble gas, so it doesn't want to mix with anyone else. So helium is all on its own. Oxygen's a bit different. Oxygen likes to go around with one other oxygen atom. So oxygens go around in pairs, and it just happens that oxygens are joined together with two of these little plastic bonds. So that's O with a little 2 for oxygen. Now the next one is going to be water, and I'm going to use the red atom just to represent oxygen. Remember, oxygen atoms are not red, they have no color. Helium atoms aren't black, but I'm going to just use the colors to help me remember what I'm building. So that's the oxygen, and I'm going to add 2 H's. So there I have O and 2 H's, H2O. Let's go on and do some carbon dioxide. So I'm going to use a black one to represent carbon, and I need 2 oxygens. I'm going to just borrow these 2 oxygens, and I'm going to make carbon dioxide, and di means 2. So I'm going to need 2 oxygens, dioxide, and when I write it down, there's the carbon dioxide. When I write it down, I use the little 2 next to the O, which means there are 2 oxygens and 1 carbon. Okay, molecule of a slightly different type is going to be sodium hydroxide, which looks like this. Sodium, oxygen, hydrogen, and there are only one of each, so we don't need to put any numbers in. So I'm going to choose a green one for sodium, and I'm going to connect it to an oxygen, which I'm going to choose red again, and I'm going to connect that to a hydrogen. And to help me remember, I'm going to use the white one for hydrogen. So there is my sodium hydroxide molecule. There's the sodium and the oxygen and the hydrogen to make sodium hydroxide. Okay, next I'm going to build one of my favorites because it's a very regular shape. It's called methane, and it starts with a carbon atom right in the middle. Methane is a greenhouse gas, which is even more environmentally damaging than carbon dioxide. So methane has 1 hydrogen on the end of these little connectors. So it's got 1 carbon atom, and eventually it's going to have 4 hydrogens. So that's, you can see it's a nice regular shape. So that is methane. Got 1 carbon and 4 hydrogens. Okay, I'm going to change one aspect of this molecule and turn it into methanol. Methanol, you can hear from the word, it sounds a bit like alcohol, but it's a different alcohol called methanol. So, just made a few little changes. That looks to me a little bit like, maybe a little puppy. So I'm going to change it around actually. So this one is carbon and 3 hydrogens. It's got a carbon and 3 hydrogens. And just to show a little bit how it's made, it's connected to 1 oxygen, and that's connected to 1 hydrogen. And this is methanol. And I'd like to just tell you a bit about methanol. It's a very poisonous substance. About 10 milliliters of ethanol, if you were to drink it, can make a person blind. And between 50 and 100 milliliters of methanol is enough to be fatal. So methanol is very like alcohol. You can't tell what it is by looking at it, but it's an extremely dangerous form of alcohol, methanol. So methylated spirits used to have methanol in it mixed with ordinary alcohol, which made it very dangerous to drink. So that's science keeping you safe. Stay away from methanol. So here is the first rule for writing formulae. When non-metal elements are found in a compound, the endings change to "ide". So the example we saw yesterday was sodium and chlorine turned to sodium chloride. Have a look at these formulae on the left hand side and follow the lines to their names. So start to get used to the names. For example, the top one is phosphorus trichloride. The tri stands for 3. And the next one down is nitrogen monoxide, and the mon means that there's 1 oxygen. And have a look at the others. Get used to mon, di, and tri. So now that you've had a go at those, write the elements that each of the following compounds are made from. Just the elements. So the top one's done for you. Iron sulfide is made from the 2 elements iron and sulfur. So pause the video and have a go at those. And here are the answers. Pause the video again and mark your answers and correct those that you didn't get correct. Here's the second rule. When you're writing a chemical formula, the numbers to the right should be, the small numbers should be to the right of their chemical symbol, just below the line and smaller than the chemical symbols. It's called a subscript, and you can find it on the font menu in a Word document. The chemical formula also shows the relative number of atoms of each element in a compound. Relative number means how many of one type of atom there are compared with another. So here's a good example. The chemical formula of carbon dioxide is CO2. There is 1 carbon atom for every 2 oxygen atoms. But in the next one, this is carbon monoxide, so it means 1, so it's 1 carbon and 1 oxygen. So 1 carbon and 1 oxygen. Here are some more examples looking at what the numbers mean. If there's only 1 of something, you don't need to write the number. So for example, helium atoms, as we heard earlier, go around on their own, doesn't need a number. There's 1 magnesium with 1 oxygen, and again that doesn't need any numbers. But for this one, with beryllium chloride, for every 1 beryllium atom there are 2 chlorine atoms, so BeCl2, and the bottom one is iron oxide. And for every 2 iron atoms, there are 3 oxygen atoms. Now pause the video again and try to match these four formulae with the particle diagrams or the molecules, and use the key on the right hand side to help you. Pause the video and do that, please. Right, and here are the answers. So check your answers and then move on. Here's the third rule, and the example is on the top right hand corner, HF, which stands for hydrogen fluoride. In a chemical formula, if there's only one of a particular element, we don't write the number. Okay, now if you use the key on the left and the pictures A, B, C, D, E, and F, you can write the formula for each of the following substances. For example, at the bottom, they've got one black circle, which is the carbon atom, and two circles with vertical lines, and those are the oxygen atoms. So there are two oxygens, one carbon, so the example would be CO2. So once again, pause the video and see how many of those you can do from A to F. And there are the answers for you. So again, pause the video and check your answers. Good. Here's the fourth rule. When you are writing a chemical formula, the elements are generally written in the same order as the rows on the periodic table. So in other words, hydrochloric acid would be H followed by Cl, sodium chloride would be Na followed by Cl. Generally from the left hand elements are first and the right hand elements are next. Here's a challenge if you want to accept it, and it's again pause the video and write down the answers. But what we're going to do is to use our we're going to make some chemical reactions using our formulae for molecules, and I've done the first one for you. Okay, so I've got hydrogen and chlorine making hydrogen chloride, and we know that hydrogen is H2, chlorine is H2, and it makes HCl. So these ones you should know. Hydrogen is whatever it is, remember the small number. Oxygen is whichever one it is, remember the small number, and it makes water, and I'm sure you know the formula for water. So pause the video and try those three, and then we can move on. Okay, good. So your task for today is to write a list of instructions for writing chemical formulae and include the four rules that we need to follow to make sure we write formula correctly. So how do you feel you did? Can you name and write symbols for some common compounds? Can you use the rules for writing formulae? And can you interpret them? Which one of those guys are you? So that's the end of today's topic, and it's the end of the chapter on elements, atoms, and compounds. So don't forget to complete any worksheets or experiments, and look at the guys on the right. They're both very happy to have finished this topic.